Hello, everyone. This is Tim Mittner with Two Point Software, and today I want to talk with you about our deployment tools, namely our iPXE Anywhere and our OSD Toolkit. Now, both of these tools work together in order to make operating system deployment easier and more scalable while also reducing your network infrastructure. Our iPXE Anywhere solution is based on the open source solution for iPXE, and we've built some automation, some menuing systems around that, and allow you to do customization of that of your OS installations. And our OSD Toolkit solution is what allows us to integrate into your task sequences inside of System Center Configuration Manager or Microsoft Endpoint Configuration Manager or Intune Configuration Manager, whatever you want to call it. Both of these solutions, like you said, work together in order to make OS deployment easier. So I thought I would jump right into it, and I will start with booting up one of my systems. And you can see here that we're just doing a standard PXE boot. In this particular environment, I have a PXE server on my local network segment, but it wouldn't necessarily have to be. A PXE server can reside either anywhere on your corporate network, or it could reside on the public internet. We can work either way, and that's one of the advantages and the beauty of using the iPXE solution is you can download most things over HTTPS or HTTP. So let's talk a little bit about that. What you just saw is we booted up, we sent a PXE request, and we downloaded via TFTP, Trivial File Transfer Protocol, a very small boot file. It's about 450K in size is what we transferred down to the machine. When that loaded on the machine, you started to see the menuing systems, and you might have seen as it flashed by really quick, we started making calls to our iPXE Anywhere web service in order to bring up this menuing systems and start the installation process. So you can see here, I have a number of menu options in my local environment here. I can build with Configuration Manager. I can build with another system that you might want or have, or I can build from cloud. So I can actually connect up to a cloud-based server in order to do my installation. Now, in my environment, I PXE booted directly off of a PXE server that is local to my network segment, but it doesn't necessarily have to be the case. You could have a PXE server that boots over the internet itself. In this particular case, I'm going to go ahead and kick off an installation from the cloud, from PSD. And you can see here, I'm making some calls to my local server, and then it's starting to make calls directly to this HTTP source, which is out on the internet to download things. And I'm downloading the lighttouch PE underscore 64.wim from the internet. And it's starting to download. Now you'll notice here, I'm not getting any information from peers. So that's another advantage of our iPXE Anywhere solution is that we can leverage peer-to-peer or branch cache for doing our OS installations, including downloading the boot WIM itself. And so if I had peers for this particular boot WIM, I could pull directly from those peers and prevent that traffic from growing across the network. Now, while this is loading, let me explain to you a little bit about how this works if you were to do a full boot over the internet. Now, you might be wondering, how do I do a PXE server on the internet? Well, like I said, you just have to download the smaller 400, 500K file over the internet via TFTP. So you can accomplish that in a couple of different ways. You can do that by setting DHCP options and basically redirecting your DHCP request for network boot to point to that server that resides on the internet. The other option that you have is to use a USB stick, a USB device. Now, when I say a USB device, everybody always has a lot of baggage when it comes to USB devices because they're used to USB devices getting out of date or containing sensitive information. And that's not the case using the 2Pints products. One, our USB boot device, all it really contains is that 400K boot file that resides on that. So it doesn't have to be a huge USB stick. It can be a small USB device. And we will use that to connect up to your cloud server, your cloud HTTP server, in order to do the download. You do have the option of actually putting branch cache, and I'll cover more of that a little bit, but you can put branch cache on the USB stick as well, which is fully encrypted by Microsoft, and there's no way to extract the data from that system. So it gives you some advantages. So while that's running, let me show you what this looks like from a configuration manager standpoint. So I'm going to start a new installation. Now you'll notice here there's this little lock, and you can see for Hyper-V I have secure boot disabled. Hyper-V is only trust Microsoft specific certs. However, we have gone through the painstaking process with our iPXE newer solution to get our binaries signed by Microsoft. So when you're booting from a physical device, that physical device can have secure boot enabled on that system. And then we'll continue to work. We are the only vendor that's gone through the process of getting their custom EFI files signed by Microsoft. So you can see here I've booted up, and let me just move this one out of the way so we can focus. You can see here I've booted up, and I'm now presented with an authentication mechanism. Now, all of this authentication mechanism are controlled through scripts that reside on your distribution point, on the PXE server. And so you can customize this however you want. You can have a traditional username and password. You can do a QR code that needs to be scanned and entered. There are a lot of different options. Anything you can think up or dream and write code with PowerShell, you can use as an authentication mechanism in order to log on and get access. Now, in this environment, I'm just going to use a simple PIN. So I'm going to enter in the answer to the life, the universe, and everything, 42, and hit enter, and that authenticates me. Now I've got my options. I can do my boot from cloud, which I just showed you. But in this case, I'm going to build with Config Manager. So at this point, our backend system, our PXE system, has reached out to Configuration Manager and presented the list of task sequences that have been deployed and made available for this particular endpoint. So in this case, I've got install Windows 11 and install Windows 10 Enterprise. So I'm going to go ahead and install Windows 10. And you can see that I'm starting to download from this distribution point. In this case, I have peers on the network that I'm pulling from. So I am fully downloading this content. 100% of this content is coming from peers, and you can see that I've downloaded that bootwim in just a matter of seconds. And now I'm basically making a call to call our web service to say, hey, we're starting the process so that we can track our deployment process. So let me show you what this looks like a little bit on the back end. So here I'm on a distribution point that's running the iPXE Anywhere Web Service and Tanium to PXE. Those work together for our iPXE Anywhere. Inside of here, we've got a folder called scripts. And you can see here, this is our authentication. So our authentication scripts is basically what defines those authentication screens that I had on there. And you can modify this to your heart's content. You can modify the menuing system. You can modify how we interact with Config Manager. You can modify how we connect up to your PSD that might sit out in the cloud. So if you want to do custom deployments, you're not tied to just deploying with Config Manager or just deploying with PSD. We have customers that are using their own homegrown or their custom built solutions for doing operating system deployment, and they just need a mechanism to PXE boot those systems. Out on our GitHub sites, we have a number of scripts that are available. So github.com/2pintsoftware, and then iPXE Anywhere. You can see here some of the scripts that we give an example. So an example device authentication script that prompts for a username and password, some default menuing system, that PSD for connecting up to a remote PSD systems. These are all available as examples that you can use to create your own customizations for doing your installation. So let's go back, and you can see now I'm booted into my configuration manager task sequence. I didn't have to choose the task sequence, and that's because we are actually pre-populating information that we gather from those iPXE screens, and as well as making calls to a backend database to pre-populate information about this deployment. So if I want to auto-name computers, if I want to install packages, I can have all that information coming from our backend database. So I'm going to go ahead and kick this off here and do my installation. And this is just a standard OS deployment task sequence. I'll show you the details. I'm actually setting some iPXE variables. I'm enabling branch cache. So that is an advantage that we have as well, as normally Microsoft does not allow you to turn on branch cache from inside of Windows PE. But we have enabled that capability, and that's what allows us to do peer-to-peer from even within Windows PE. So it's starting to download and is moving along at a pretty good clip using peer-to-peer technology through branch cache. Now, normally when you do peer-to-peer, Microsoft limits the speed in which peer-to-peer can be done, and we wanted to make an OS deployment go as fast as possible, especially when you're doing peer-to-peer. So we have some technology called OSD Turbo that will remove the throttling that Microsoft puts in place to allow us to achieve these higher speeds. And generally in my environment, I see anywhere from around 400 megabit to 600 megabit per second in order to do that. Now, I mentioned earlier that you could do a USB install. And when you do a USB install, you do have the option of putting branch cache on that USB stick. And when you do that, what it will do is it will pull this as if it was from a peer from that USB stick. So when you're doing an OS installation from a USB stick, you will see speeds of 2000 plus megabit per second when it's pulling that WIM file. So it allows you to do a full end-to-end OS deployment in 15 to 20 minutes off of that USB stick, which is pretty impressive. So now it's just running and kicking off a normal task sequence. So let me show you what this looks like from within Configuration Manager. So I'm going to go ahead and pop open my task sequence here. And you can see here that we've really just added a few steps in order to make this work. So first thing we need to do is set the alternate content provider. So you just set SMSTS download program to bitsacp.exe. Now, bitsacp.exe is a binary that we provide inside of our OSD Toolkit, and you just need to include that as part of your task sequence in order to enable this alternate content provider. If you're licensed for Turbo, you can enable Turbo again to remove the bandwidth speed limitations of bits and branch cache from within inside of Windows PE. Last thing we need to do is just to enable branch cache. So we do that just by running this BC enabler, and we enable branch cache, we give it a path, and then a version of branch cache that we want to support, and then the port that we want to run branch cache on. Now the fascinating thing is here is you can have branch cache running and serving peers even when it's within inside of Windows PE. So if I were doing multiple deployments and you saw that I already downloaded the WIM in that previous task sequence that I was running, that WIM file could be served up to other systems on the network. But one thing that we want to do is make sure, as we've downloaded all that data within Windows PE, that we don't lose that valuable cache data when we transition to the full operating system. So we have a step later in the task sequence that moves the branch cache data from Windows PE to the full operating system so that when it reboots into Windows, it can actually start servicing as a branch cache peer in order to do the installation. And that's really all that needs to be done. Now, you can do other things. We do give you the ability to integrate Stifle-R. If you haven't watched my video on Stifle-R, please go back and watch that. But you can integrate Stifle-R into the boot image itself so that we can throttle the network speeds for the OS deployment process in conjunction with the rules of that network. And this will also automatically configure the branch cache information even while you're inside of Windows PE. So we have that capability as well. So let me go back. You can see here that I'm now installing my configuration manager client on the system. So that is about wrapped up, and it's going to go into the full operating system. So let's go back here, and you can see that my PowerShell deployment booted and loaded everything over the internet. So it's doing my normal PowerShell deployment, and I can go ahead and kick off my installations of my operating system through PSD here. Just provide all of this information. I am in Central Time Zone and do my installation. And now you can see I'm accessing and running that task sequence from that internet-based server. In this particular case, it is a service that is running inside of Azure. So you can run this in Azure and Amazon. This could be in a endpoint network or edge network device that's running on your network as well. So go out to our website. Please check out our iPXE Anywhere, our OSD Toolkit solutions inside of here. We have a lot of great information. We have some great information on how to do cloud imaging, a solution briefing on how that would work. Another thing is we are very transparent about our pricing. So we have different pricing based on if you are a private sector, a commercial organization, or a public sector in education or a government institution. So we're very transparent. So everything I just showed you on the commercial side can be purchased for basically $2.30 per endpoint. And the price is even less expensive for the nonprofit organizations. So that's our iPXE Anywhere and OSD Toolkit solution in a nutshell. Thank you very much for your time. I greatly appreciate it. And please subscribe and get notified for future videos. Thank you.